Flixbro, 1974. A temporary bypass pipe, never properly engineered, rips apart under pressure. 28 people never make it home. Bhopal, 1984. A tank of methyl isocyanate, safety systems disabled, understaffed, under pressure to cut cost, and a gas cloud that kills thousands. Piper Alpha, 1988. A permit to work handover failure. One night shift does not know what the day shift did. 167 men die on a burning platform in the North Sea. Texas City, 2005. A startup, an overfilled tower, a blowdown stack venting straight into a crowd of contractor trailers. These aren't old stories, they are the reason almost every process safety rule you follow today exists. Someone paid for that rule before you ever read it. In the first episode of Process Safety Conversations, we will explore how process safety has evolved and why it matters more than ever. So let's get the conversation started with your host Muhammad Obaid Athar.
Today, we are going back to the beginning what process safety really means, how it evolved, and why in 2026, with smarter plants than ever, it still matters as much as it did the day FlexPro happened. Every episode, we'll sit down with someone who's lived this work, not just studied it, and get into the parts of process safety that didn't make it into the training slides. For episode 1, I couldn't ask for a better guest. Joining me is Mr. Hisham Hanafi, principal consultant and a functional and process safety expert, CFSC and CCPS certified, with deep hands-on experience across HAZOP, LOPA, SIL verification, Bowtie analysis, major hazard risk management on some genuinely complex assets, and you name it. Hisham, welcome to the show.
Thank you, Obaid. Genuinely glad to be here, and honestly, a bit honored to be the first guest on this. I know how much thought you have put into building this platform, so I don't take being episode one lightly.
Thank you for your kind words, Isham. Before we get into the history of why process safety matters and what is the significance of it, I would like to know that how did you end up choosing a career in this field? Because when I graduated as a chemical engineer, we were not aware of this field. We only knew that either an operations engineer exists or a process engineer exists. And when I joined my job, only then I came to know about what really process safety is. So, how was your experience? How did you end up choosing a career in process safety?
Fair question. So I was trained as an engineer, like most of people in this field, and honestly, I didn't set out to do process safety. My introduction to process safety came from being caught out, if I can say so. Early in my career, I was a process slash operation engineer at a remote facility. About a year after, we had an insurance audit, and the auditor asked me about our LOPA report. I had no idea at that time what LOPA even stood for. So he raised an action on the company to train the engineers on PHA, HAZOP, and LOPA, and so on. Actually, that training was my starting point, and I have been in process safety ever since. I sometimes joke that I owe my career to an audit finding written against me. From there, I moved from general process operation engineering into functional and process safety, specifically cell studies, SIS design, LOPA, and so on. Because I wanted to work on the layer that actually has to perform when everything else has already failed. Over the years, that's taken me across hazard facilitation, LOPA, Bowtie work, and major hazard risk assessments on some fairly complex high consequence assets. I got my CFSE, CCPSC along the way, partly due to the partly for the discipline of the exams, but mostly because I wanted an external proof to myself as much as anyone else that I actually knew what I'm doing. I still think the best teacher in this field isn't the certification, though. It's the first time a scenario you dismissed as not credible turns out to be exactly what happened somewhere else a few years later.
That's very rightly put because you are absolutely right. Certifications alone do not guarantee that you will be a good process safety engineer. It's about the knack that you have and the experience that you live that ultimately teaches you a lot. And when you sit in conversations or in forums in which all those studies are being conducted, only then you know that you have the interest to execute those and be a good expert in this field. So, Hisham, without like delaying it further, we'll start the first segment of our episode in which we'll talk about what process safety really means. Because although this question sounds very simple, but if you ask different people about the definition of process safety, obviously everyone will have their own explanation. And what I feel over the period of time is that usually people interrelate occupational safety with process safety. So, Hisham, in your words, what is process safety and what is it not?
Yeah, so the simplest way I explain it to someone outside the field is to differentiate between personal safety and process safety. So, personal safety is about protecting one person at a time, not to slip, not to fall, to wear the gloves, safety shoes, and so on and so forth. While process safety is about preventing the uncontrolled release of energy or hazardous material that can hurt many people at once, damage the plant, or affect the community outside the fence. So the core event we are always trying to prevent is loss of containment, something that should have stayed inside a pipe, a vessel, a tank, separator, or whatever, escaping when it shouldn't have. And the statistics behave completely differently. Personal safety incidents are high frequency with low consequences, while um, while the process safety events are low frequency with high consequences, maybe very severe consequences. You might go 15 years without major loss of containment, and then when it happens, it will be catastrophic. That's what makes it so dangerous to manage. The absence of incidents feels like safety, but it can just as easily mean you haven't been unlucky yet.
Yeah, you are absolutely right because that distinction, process safety versus personal safety, is one people usually nod along to, but they don't really, get that core concept. Can you give an example where a plant looked safe on every occupational metric, like good TRIR score, clean safety walk audits, and but it was actually sitting on a major hazard which people were not aware of?
Yeah, actually, I have walked into more than one site like this. Uh, Excellent housekeeping, contractors in full PPEs, a safety board out front proudly showing 3 years without lost time injury, and then you get into the process hazard analysis and find relief valves that haven't been inspected on schedule, an SIS system that has been sitting in bypass for months because operations temporarily needed the flexibility. Yeah, or an MOC for a control philosophy change that was never formally closed out. None of that shows up on a safety walk, of course. You don't see a Starver process safety program by looking at how tidy the plant is. You see it by pulling the maintenance backlog and the overdue action list and so on.
That's you're absolutely right because that's the trap, right? You can hit zero recordables for years and still be one, major uh, shortfall away from a very catastrophic event because the metrics in occupational safety that you're tracking don't measure the thing that, harm the people or the assets or the environment in a way that, basically highlights the gaps in the process safety regime. I'll add my own frame on this because it's something I think about a lot. Personal safety is about individual behavior. Did someone trip? Did someone reach into a machine? Whereas process safety, it is about the systems, right? Like you cannot blame a human for a design flaw. So it is very important to like dig down deeper into the systems that the organization is being run into, which overall ensure that the plant or any industry that you are working in is running safely.
Completely agree with you. And I would push it one step further. So, behavior-based safety programs can actually create false confidence at the process safety level because leadership sees engagement, sees the numbers improving, and reads that safety culture is strong across the board, but a good safety culture for slips and falls does not automatically transfer to disciplined barrier management. So they are related somehow, but they are not the same muscle, and treating them as one metric is exactly how a well-intentioned site ends up surprised with a catastrophic incident.
Yeah, perfectly explained, Hisham. Thank you so much. So I guess the audience will be now pretty much clear on what process safety really is and how it is differentiated from the occupational safety, and why having a good occupational safety score doesn't guarantee you that you are like 100% compliant to the other aspect of the process safety. So thank you so much. Now we'll move on to the next segment of our podcast, and in which we will like discuss how this entire, this subject, this process safety subject evolved, the incidents that occurred in past. So let's get into the history, because I think this is where the audience, especially young engineers, really need the context. Like every major process safety framework we use today was paid for in an incident. So let's walk through a few. I'll just name a few incidents, and we mentioned those incidents in our introduction as well. So Flixbro 1974. Walk us through what actually went wrong there and what came out of it.
Yeah, Fixboro is actually the one I always tell young engineers to start with. So because the failure is so mechanically simple, it's almost embarrassing. So one of six cyclohexane oxidization reactors had a crack and was taken out of service. And instead of properly engineering a replacement, the site installed a temporary bypass pipe between the two other reactors, supported on nothing more than scaffolding. So you can imagine. So with no stress calculation, no formal drawing, and no one senior enough asking who approved that modification. So the bypass failed under the cyclic loading of the process, released a huge vapor cloud of cyclohexane, and unfortunately, it found an ignition source. 28 people died, and the plant was essentially destroyed. So what came out of it is the DNA of everything we now call MOC, or management of a change. At that time, there was no formal MOC process as we would recognize it today. A temporary modification just happened on the judgment of people who were not qualified enough to make that call. Nobody stopped to ask what could go wrong. Foxborough is a huge part of why the UK moved towards what eventually became the KEMA and then became COMA regulation. Yeah. And why temporarily became one of the most dangerous words in the plant's vocabulary. Yeah.
True, true. And even we feel that today, when when you are in an emergency situation and there are temporary repairs, people, there is a tendency to just like do it on a hurry basis, so that the execution is done as soon as possible. But it is very important to make sure that all the safety aspects are checked before the implementation of any temporary repair. Otherwise, your plant can be under a risk of another flex pro kind of an event. So Hisham, then a decade later, Bhopal, 1984, arguably the incident that defined major hazard for the entire world. So what's your say about it?
Yeah. Actually, Bhopal is different because it's not one failure. It's a whole stack of failures all happening at once. So water got into a tank storing methyl isocyanate, a chemical that reacts violently with water. Yeah. So the refrigeration unit at that time that was supposed to keep the tank cool had been shut down to save, some operating costs. The gas scrubber that should have neutralized any escaping vapor was also offline. The flare tower wasn't sized for that kind of release, even if it was working. And critically, the land around the plant had been allowed to be filled up with dense housing and population. So when the gas cloud came out, there was no buffer or barrier between the hazard and the community. Officially, several thousand of people died and many more were permanently injured. So yeah, unfortunately, Bhopal is the incident that made the world use the phrase major hazard the way we use it today. It directly led to the formation of the Center of Chemical Process Safety, I believe around 1985. And it's a straight line from there to OSHA Process Safety Management Standard in 1992, and of course the APA Risk Management Program and so on. So yeah, it also was the reason that land use planning around hazard sites is taken seriously now. The fence line was never the actual boundary of the hazard. It just felt like one.
True, true, absolutely. And basically all the community awareness programs and like now there are, environmental studies such as EIA. Whenever you are installing a new plant, you must need to make sure that the community is at a certain safer distance to the industry, and all of those aspects were, are now being considered because of incidents which happened in the past. So it is again one of those incidents which, as young engineers and even as experienced people, we must go through on frequent basis in order to keep it in our memory line that such things happened in the past, which resulted in huge catastrophic events. So Hisham, Piper Alpha in 88, which I think is the incident every process safety engineer should study line by line, because it's not really a chemical failure, it's a system and communication failure. So what's your say about it?
Yeah, yeah, Piper Alpha is the one that still gives me chills, honestly, because every individual decision made sense in isolation. So a pressure safety valve was removed for maintenance on a day shift, and a blank flange was fitted in its place, but not fully bolted and sealed, as you know, just enough to close out the day's work. So the permit for that job was suspended, not closed, and the paperwork ended up in the wrong place at shift handover. So the night shift had no idea the valve was missing when they started the pump that was associated with that line. So gas escaped through the incomplete flange and found an ignition source almost immediately. Yeah, what turned
Yeah.
it into the worst offshore disaster in the history was everything that happened next. So the initial explosion damaged the fire suppression system and the control room. Um, at the same time, other platforms kept feeding gas and oil into Piper Alpha through shared risers because there was no way to communicate the emergency case or emergency shutdown across installations. And the firewater deluge pumps had been switched into manual months earlier because of divers working in the water. So they never automatically got engaged. And 167 men died, mainly because there was no way of the platform that didn't mean jumping into a burning sea. So you can imagine how hard was it? Yeah. Lord Collins' public inquiry is one of the most important documents in our entire field, and usually I try to reread it every while and then. So it's why the UK created the safety case regime, and it's why permit to work, discipline, and shift and over are treated as seriously as they are today. Piper Alpha proves that a piece of paper in the wrong drawer can kill 167 people.
True, true, absolutely right. And the theory that you quoted of the Lord Cullen's public inquiry is, you are absolutely right. One of the most important documents, and we should all refer to it. And it just highlights how important operational discipline is.
Yeah.
Usually, in our routine tasks, charge, handover, takeover, these sort of things, they're because of certain workload, or it becomes part of the routine, so it is not given that due importance. But such incidents tell us that how important these small acts are and how seriously everyone should, follow the SOPs and complying to them. Now, jumping forward to the Texas city in 2005, closer to our lifetimes, closer to how modern refineries actually run. So, why did that incident happen, Hisham?
Yeah, there are a lot of videos here and there, so and they are very interesting to watch. But of course, it's worth mention here that Texas City happened during the startup of an isomerization unit. A distillation tower was being filled, but the level instrumentation was giving misleading readings, and operators kept adding hydrocarbon liquid well past where the tower should have been full. So it overflowed into an old-style atmospheric blowdown stack, not a modern flare system as we know right now with the knockout drum and so, which vented liquid hydrocarbons straight up and out at the ground level. So the vapor found an ignition source as usual. Yeah, almost certainly the engine of an idling diesel truck. working there, and the explosion killed 15 people and injured over 180. Most of them were contractors in temporary trailers that had been placed dangerously close to the process unit that was actively starting up. So Baker Panel report, which is another report that we need to read every while and then as well, in my opinion, and actually it has the same importance of Collins' report of Piper Alpha because it's the first time a major investigation explicitly separated process safety performance from personal safety performance at the corporate level. And this is what we mentioned a few minutes earlier, right? So the site had genuinely good personal safety statistics right up until the explosion. The Baker panel used that contrast to argue that leading indicators, overdue inspections, bypass safety systems, aging infrastructure, and so on, matter more than lagging indicators like injury rates, and that process safety needs its own visibility all the way up to the board, not just the plant manager.
True, true. And again, as mentioned earlier in our podcast, that one should like know the clear difference between the occupational matrices and the process safety matrices, because you cannot integrate both of them and say that if one is going well, the other will automatically, support us. So in this incident, advocates that thing as well. What strikes me most about laying these four out in a row, Flexbro, Bhopal, Piper Alpha, Texas City, is that they are roughly 10 to 15 years apart. And each one exposes a completely different layer of the same onion. Flexbro, engineering rigor; Bhopal, layers of protection and community risk; Piper Alpha, human factors and communication; Texas City, culture and leading indicators. It's almost like the industry had to fail its way through every category of barrier before we had a complete picture.
Yeah, unfortunately, that's exactly right. Yeah. And if you let me add a fifth, I'll put Bunsfield explosion in
Yeah,
2005
yeah.
right alongside Texas City because it closes the loop on instrumentation specifically. A fuel storage tank at the UK terminal was being filled overnight. The automatic tank gauge had failed sometime earlier without anyone noticing, and the independent high level switch that was supposed to be the last line of defense
Yeah.
also failed to trap the process. So the tank overflowed, formed a massive vapor cloud that drifted across the site, and of course, managed to find the ignition source in one of the largest peacetime explosions Europe has seen. Remarkably, no one died, largely because it happened early on a Sunday morning. So Bunsfield is the incident that made regulators everywhere start asking, how do you actually verify that your last independent layer of protection still works? So instead of just trusting that it's here and it will be working, it's a perfect bridge into the LOPA and cell conversation we will get to shortly, I believe. So
Okay, perfect, perfect. Thank you so much for sharing that incident as well. And I guess that's really the honest answer to how did process safety evolve. And I guess we can safely say that it wasn't proactive. It was reactive, incident by incident, and the frameworks we now teach as best practice, be it PSM, COMA, CCPS 20 elements, are basically scar tissues, which is exactly why I think this history should be mandatory reading and not a footnote in a HAZOP training slide like we just mentioned usually, like as a safety pause that this incident happened. But it is very important to recall them, but it is very important as well to take learnings from them and make sure that whatever the systems that were developed after those incidents are being followed at site as well, because otherwise all of those learnings are there for us to make sure that we run our plants in a safer manner. So now, Hisham, coming to the next part of the podcast, like process safety evolved. We had a lot of incidents that taught us what were, the neglecting areas or what were the areas of improvement in which the industries had to work. So now that all has been set, and since there is no process that is 100% efficient, obviously a lot of more learnings are coming into the place. But so now let's talk about today. Plants are more instrumented, more automated, more monitored than ever they have been. So why does process safety matter more and not less in 2026?
yeah, yeah. So plants are more instrumented, more automated, more monitored than before. However, we still see a lot of incidents here and there, and actually they became nearer to our places as well, if you read the news and so on. Yeah, so a few things are stacking on top of each other right now. First, a huge number of assets globally are running well past their original design life, right? With decades of brownfield modifications
Yeah.
layered on top of the original design intent. Every one of those modifications add a complexity that the original HAZOP never saw. Second, the workforce that built and understood these plans actually are retiring, right? And a lot of that knowledge was never being written down. So it just lived in someone's head, right? So the third point is those plans are more interconnected than ever. Shared utilities, shared control systems, tighter integration between units, which means a failure in one place can propagate faster and further than it used to. And now you add a generally new risk category on top of all of that, cyber physical risk or cybersecurity risk.
Yeah.
A modern SIS is a piece of software as much as it's a piece of hardware, and that opens the door for explorers engineers never had to think about, right?
You're absolutely right. And I guess the experience gap is one I feel personally. A huge percentage of the process safety knowledge in this industry lives in people who are like, I guess, within 10 years of retirement. And if we don't actively pull that knowledge out of their heads and into our systems, as of files, Bowties, lesson learned databases, we are going to relearn FlexPro's lessons the hard way on our own watch. But the good part of the modern era is that the documentation is very aligned. Like we have our systems, we have our standards, everything is published. So it is like it is good in a way that the information is very accessible and reachable, rather that in the old eras there was, everything was in the hard form. It was limited access. But these days we have the liberty to access knowledge easily while sitting in our homes. So, but again, this is a very important point.
Yeah, totally agree with you. However, that is exactly the risk that worries me the most. Yeah, more than any single technical hazard. I have sat in a HAZOP revalidation where only one person in the room who remembered why a particular scenario was recorded. And
Yeah.
that particular person was someone 18 months from retirement. So you can imagine if he hadn't been there in the session, the team would have quietly dismiss dismiss that scenario, right? Because it looked irrelevant on paper. So digitalization, yeah, can help here, but it's a double-edged sword. Take care of that. A beautifully organized Bowtie library or a smart lessons learned database is only good as what gets fed into it. Yeah.
True.
And the people who most need to write down what they know are usually the busiest ones on the site. My honest advice to any organization is to treat capturing that tribal knowledge as its own project with its own budget and deadline, not as something that happens informally if someone finds time.
True, true. And I guess but there's also a complacency risk that comes with good performance. The longer a plant goes without a major incident, the easier it is for leadership to quietly reallocate the process safety budget towards things with visible, immediate return. Piper Alpha and Texas City both had periods of very strong occupational safety performance right before the disaster. So, as a lesson learned, good numbers can hide a starving process safety program as well. So, we should all be very careful about it. So, Hisham, like we have discussed a lot about how process safety evolved and various other aspects. Now, let's get a little practical. Like for someone listening who is early in his or her career, or maybe outside process safety entirely, what actually stops a Bhopal or a Piper Alpha from happening at a well-run site today? Walk us through the process safety toolkit.
Yeah. So it's a very tricky question, because there is no in process safety world there is no right and wrong answers, and I believe you agree with me on this part.
Yeah, yeah,
But
true. Everyone has their own explanation to certain things in process safety.
yes, as long as you have the justification, yeah, we are okay. So, in my point of view, it starts with HAZOP or Hazard Operability Study, which is a structured guideward-driven review where a multidisciplinary team walks through the design line by line, PNIDs, whatever, nodes, yeah. And they ask themselves, what if we get no flow here, or higher pressure there, reverse flow, no, more flow, and so on and so forth. Multiple deviations and guide rules, yeah. And works out the causes and consequences of each deviation. That's your hazard identification step. Once you have identified a scenario, LOPA, or layer of protection analysis, lets you check semi-quantitatively whether you actually have enough independent layers of protections, or IPL, to bring
Yeah.
the risk down to the tolerable frequency. If LOPA tells you that you need a safety instrumental function, that's where cell comes in. And with the cell here, we mean safety integrity level, which sets how reliable that specific automated needed trap needs to be. Of course, we need to refer to different standards, especially the IEC 61511 or IEC 61508, and drives how you design, test and maintain that safety instrumental function. Yeah. Of course, a Bowtie is also a tool that ties all together visually. So the threads on the left, top event in the middle, or the knot, as we call, with the consequences on the right hand side, and of course every barrier in between drawn out so that someone with no engineering background can look at it and understand what's standing between a credible cause and a catastrophe.
Yeah, but very, very well explained. And I guess to all the young engineers and those people who are like stepping into the process safety career, the studies that Hisham just mentioned are very important, and you should like understand the basics of these studies from from the start of your career, because these are really the breathing toolkits of process safety. I'd like to mention the last point, and I guess the people usually miss that a bow tie diagram doesn't protect anyone. Like, let's just be very clear on this. It's just a visual representation of all the protections that exist at site. The actual safety comes from whether that safety valve was tested this year, whether that sys logic solver still matches the PNID, or that MOC for that temporary bypass ever got closed out. So documentation is not a barrier; it's a record of a barrier. So we should like have this clarity in mind.
Yeah, so I kind of agree with you more. So, yeah, that's exactly the line I use with my different, clients. And so a bow tie or a HAZOP report or a hazard report or whatever is a promise, not a guarantee, right? And the gap between the two, I mean, i.e. the promise and the guarantee, is how you maintain, test those safety critical elements, safeguards, IPLs, and so on, and how you deal with your changes. How about the MOCs and so running in your facility? So every one of the incidents we just discussed a few minutes earlier had a document somewhere that on paper said the hazard was controlled. Piper Alpha had a permit system.
Yeah.
Bunsfield had an independent high-level switch on the drawing. The failure was never in the design intent, right? So it was in whether that barrier was actually verified to be doing its job on the day it mattered or not. That's why I tell every client, every concerned person the same thing. Your proof testing schedule and your overdue action list can tell me more about your real risk profile or exposure than your bow tie library does.
Yeah, that's absolutely right. And no matter how fancy the bow tie may look, deep down, if you like investigate the system, there might be a lot of gaps in it. So, like, if you had to boil it down to one sentence for a plant manager who thinks process safety is a cost center, what would you tell them?
Yeah, and actually, this is a usual debate point. Yeah. So actually, process safety isn't the cost of doing business. So it's your license to keep doing business. So because the moment you lose the containment on a major hazard, you don't just lose the money, you lose the right to operate. And sometimes you lose people who are never coming back.
True, true, absolutely. So, Isam, thank you so much. I guess we have covered what process safety is, how it evolved, why it matters the most even today, and how process safety basically stops a major accident, event from occurring. So, before we close out this podcast, I would like to just ask a few rapid fire questions. And I would just want to hear a very honest answer from you without thinking anything that comes into your mind when I ask these questions. Because since you have a very like versatile experience, you have been around the world, and I'm sure you must have some inner thoughts which you can easily relate to when I ask these questions. So the first question is, tell me about one incident every process safety engineer should study, even if it's not on the standard list.
Oh, that's a nice question. Everyone is starting process safety, technical safety, and so usually they watch the videos, read the reports of the previous incidents we discussed, right? But there is a one which is related to West Fertilizer Company, Texas, happened in 2013, where the ammonium nitrate was stored in wooden bins in a
Yeah.
wooden building, no sprinkler system, right next to residential area and a school. So it's not as famous as the other ones we discussed and maybe some others. But for anyone in fertilizer and ammonia related operations, it should be required reading.
Okay, perfect. The most common myth about process safety you still hear on site.
Oh, yes, it's the usual sentence I hear everywhere. We have gone years without an incident, so we must be doing something right. Yeah,
Yeah.
okay. This is not an evidence of safety, right?
Yes.
That's the absence of bad luck. And it's the most dangerous sentence in this industry.
Okay, so one habit that separates a good HAZOP facilitator from a great one. I know this is like a bit functional question. We haven't discussed
Yeah.
HAZOP in that depth, but then again, from your experience, what's the one thing that separates a good HAZOP facilitator?
So I have a rule that I usually tell the people in the HAZOP meeting about that there is no silly question, there is no silly opinion. So therefore, the good facilitator doesn't fill silence; they use it, right? So the best ones I have ever worked with, and actually I'm trying to follow the same approach, will let an awkward pause sit in the room for 10-15 seconds after a deviation, because this is where usually the quietest engineer in the room finally says the thing they were too unsure to say immediately. Maybe they are thinking inside their head, and so then they decide to talk about a specific issue or a problem.
True, true. Very, very, very well said. So, if you could mandate one thing industry-wide tomorrow, what would it be?
Oh, yeah, this one is a tricky one, and yeah, it can be a double-sworded one, but let's discuss it. So, if I could mandate one thing, it would be the independent verification and closure tracking on every PHA action item. However, we need to make sure first the PHA study was done as per the standard and so on and so forth. Because some actions are not really relevant, but if they are relevant, we this independent verification and closure tracking, of course, with real consequences for actions that go overdue. An action sitting open for 3 years, of course, is not a paperwork problem, right? It's an unmanaged hazard.
True, true. Last question, Hisham. Advice for someone starting out in process safety today.
Oh, yeah. So maybe I will start with what my manager asked me to do 15 years ago. Go stand next to the equipment before you ever open the PNDD. Walk the unit, talk to the operators, and for every line you eventually draw on a drawing, ask yourself, and you need to honestly ask yourself, how could this line kill someone? If you build that habit early, everything else in this field gets much more easier.
Very, very valid point. Hisham, this was exactly the conversation I wanted to open this show with. Thank you for being our first guest and for being generous with a career's worth of hard earned lessons. The things that you mentioned, the advice that you gave to young engineers, and the overall the process, how the process safety evolved, and from the historical aspects to the current scenarios, it was a very well, spoken podcast in which I'm sure all the people who will listen to it will have a lot of learnings from this episode. To everyone listening, if this is your first time here, this is Process Safety Conversations. We are not here to recite standards at you. We are here to talk about why those standards exist and what they cost, what it actually takes to keep people alive in industrial operations. Follow the page, share this with someone in your plant who needs to hear it, and tell us what's the incident that changed you, how you think about process safety. We want to hear it, and it might shape a future episode. I am Obaid Athar, and this was our first episode on process safety conversations. How you think